Every time you visit a website, a silent conversation happens behind the scenes. Your browser says, "Hey server, I need this web page." And the server replies, "Here you go." But how does this invisible communication actually work? In this video, we'll explore the basics of HTTP, or Hypertext Transfer Protocol, the system that makes the web work seamlessly. By the end of this video, you'll understand how browsers and servers communicate, the role of HTTP methods like GET and POST, why HTTP is stateless but websites still remember your information, and how HTTP fits into the bigger picture of the OSI model. Let's dive in. First things first, what exactly is HTTP? HTTP stands for Hypertext Transfer Protocol. It's the set of rules that allows your browser to talk to servers and exchange data. In simpler terms, it's the language that browsers and servers use to communicate. When you type a URL into your browser and press enter, HTTP acts like a messenger. It ensures that the browser, your client, and the server, where the website is stored, can send and receive information correctly. Let's talk about the request-response cycle, which is the backbone of HTTP. Here's how it works step by step. 1. The browser sends a request. When you visit a website, your browser sends an HTTP request to the server. This request contains information like the type of data it wants and what web page you're trying to access. 2. The server processes the request. The server looks at the request and prepares the appropriate response, which usually includes the files needed to display the web page, like HTML, CSS, and JavaScript. 3. The browser receives the response. The browser takes the response from the server and renders it into the website you see on your screen. One important thing to know is that HTTP is stateless. This means that each request and response is completely independent, and the server doesn't remember anything about your previous interactions. For example, if you refresh a web page, your browser sends a brand new HTTP request, and the server treats it like a completely new interaction. But wait, how do websites like online stores remember your cart items or keep you logged in? The answer lies in sessions and cookies. Sessions. The server assigns you a unique session ID and stores it temporarily. Cookies. These are small pieces of data stored in your browser that track your activity across different requests. By using sessions and cookies together, websites can simulate a memory, even though HTTP itself is stateless. To really understand how HTTP works, we need to zoom out and look at the OSI model, which stands for Open Systems Interconnection Model. The OSI model is a conceptual framework that describes how data travels from one device to another across a network. It breaks this process into 7 layers, each with a specific function. Think of it as a step-by-step assembly line, where each layer handles a specific task before passing the data to the next layer. Here's a quick breakdown of the 7 layers of the OSI model. 1. Physical layer. This is the bottom layer, responsible for the actual physical connection between devices. It deals with things like cables, switches, and signals. 2. Data link layer. This layer organizes data into frames and makes sure it is error-free during transmission. It works directly with the physical layer. 3. Network layer. Responsible for routing data between devices. It uses IP addresses to figure out where data needs to go. 4. Transport layer. Ensures reliable data delivery through protocols like TCP, Transmission Control Protocol, or UDP, User Datagram Protocol. This layer breaks data into smaller chunks called segments. 5. Session layer. Handles the creation and management of sessions, basically, ongoing conversations between 2 devices. 6. Presentation layer. Prepares data for the application layer by translating it into a readable format. This includes encryption, compression, and other transformations. 7. Application layer. This is the topmost layer, where HTTP operates. It's responsible for high-level communication between applications, like your browser and a server. Application layer is the layer closest to the end user. This layer doesn't deal with the actual transmission of data that's handled by the lower layers. Instead, it focuses on how applications, like your web browser or an email client, interact with servers over the internet. When you type a URL into your browser, HTTP handles the high-level communication, such as formatting the request, ensuring the server understands it, and interpreting the response so the browser can render the web page. Below the application layer, the transport layer ensures the data is delivered reliably using TCP, and the network layer handles routing the data between your device and the server using IP addresses. In other words, HTTP depends on the lower layers to get the job done. Now let's get into HTTP methods. HTTP includes several methods that define what kind of action is being requested. The two most common ones are GET. This method asks the server to send back information. For example, when you load a web page, your browser uses GET to fetch the HTML, CSS, and JavaScript. POST. This method sends data to the server. A common example is submitting a form, like when you log into an account or post a comment on a blog. There are other methods like PUT, delete, and patch, but as a front-end developer, you'll primarily work with GET and POST. Every time the server responds to a request, it also sends back a status code to indicate how the request went. Here are some common ones you'll encounter. 200 OK. Everything went well, and the browser received the data successfully. 404 not found. The server couldn't find the requested resource. 500 internal server error. Something went wrong on the server's side. ASA developer. Understanding these status codes can help you debug issues when something doesn't work as expected. Now you know how HTTP works, why it's stateless, and how it fits into the OSI model. But there's still so much more to learn. In our next video, we'll explore domain names, what they are, how they work, and why they're so important for accessing websites easily. If you found this video helpful, give it a thumbs up, subscribe to Frontend Repo, and hit the notification bell to keep learning. Thanks for watching, and I'll see you in the next video.